So good morning, children. This is 12th Physics, Unit 6, Optics. So we are going to start with the chapter 9, Ray Optics and the Optical Instruments. In that, the first topic, which is in your syllabus, starts with refraction and laws of refraction. So we know what is refraction. That is the phenomena of bending of light, right? When light enters from one medium to another, the light bends. So that is known as refraction of light. This is known to us, right? So the change of path, bending of light is change of path when it enters from one medium to another. We even know the reason that why does this change of path, why does this bending of light takes place. As the light enters from one medium to another, here you can see the light is entering from air to water. Suppose you are having a bucket which is filled of water. So inside the bucket, the medium is water, and just outside the bucket, it's air. So that will be the case over here. So if light enters from air to water, as they are two different mediums, the bending of light will occur, that is, refraction will take place due to change in the speed of the light. The speed of the light in different medium is different. So due to this difference in the speed of the light, the bending of light or the change in the path of the light takes place. So this is the cause of refraction, right? Now, let's talk about the laws of refraction. So laws of refraction, we are very much familiar with the second point and the Snell's law, right? The first point says that when children refraction takes place, there occurs change in velocity of the light, yes, and the wavelength of the light. But children, the frequency and the phase, it depends upon source. It is totally on the source. If you change the source of light, then only the frequency or the phase may change. Otherwise, it will remain constant, right? So when refraction takes place, only the velocity and the wavelength changes, but the frequency and the phase of the light do not change when light goes from one medium to another. Okay, second point, the incident ray, refracted ray and normal and the point of incidence all lie in the same plane, right? The third point is the Snell's law, which says that the ratio of sin I upon sin R for a given pair of media. Given pair of media means here it is air and here it is air and water. So this is one pair, air and water. These are two medias. So for air and water, everywhere this ratio will remain same. Does not matter if you change your I from 30 to 50 to 60 to 70. Your R will change, refraction angle will change accordingly, and the ratio, that is sin I by sin R, will be always constant. And that constant is named as the refractive index. The refractive index, right children? So we can write refractive index, the symbol is mu. Suppose here this is medium 1 and this is medium 2. If you want to write the refractive index of medium 2 with respect to 1, so it will be written like this, refractive index of medium 2 with respect to 1. So you are going to write the sign of the medium from which the light is entering, right? So light is entering from the first medium, which is written in the initial. So there the angle is I, and for medium 2 the angle is angle of refraction, that is R. So it will be sin I upon sin R. Okay children, so here we are having a very short numerical. If you see, the angle of incidence is 30 degree, angle of refraction is 45 degree. Suppose we have been asked to find out the angle of, this is rarer medium. So angle of refractive index of rarer medium with respect to denser medium. So in denser medium, the angle is 30. In rarer medium, the angle is 45. So sine 30 is half. Sine 45 is 1 by root 2. And your final answer is 1 upon root 2. Okay, children. So answer is 1 by root 2. So this is your refraction and the laws of refraction. Here we came through a term that is refractive index. So children, refractive index is the ratio of speed of light in vacuum, which is denoted by C, upon speed of light in the medium, which is denoted by V. This is known as absolute refractive index, and it is a unitless quantity. It does not have any unit, right children? And there is one more term which says relative refractive index. Relative is with respect to something. Relative, you are having two medium. First is V1, sorry, first medium is M1, other medium is M2. M1 and M2. Suppose the speed of the light in medium 1 is V1 and the speed of the light in medium 2 is V2. Suppose the one of them is not air. Then their refractive index is known as, suppose refractive index of medium 2 with respect to 1. Then it will be given by mu2 upon mu1. देखो बेटा mu2 upon mu1 जिसका refractive index लिख रहे हो, refractive index of medium 2 with respect to 1. So with respect here, that will go down. So it is mu2 by mu1. Now we know refractive index is, this is the definition, that is C upon V2. है ना बेटा? Because mu2 is for medium 2. So V2 आएगा. Right? Similarly, C upon V1. CC will get cancelled, V1 will go up, so your answer will be V1 by V2. Right children? So this is refractive index of medium 2 with respect to 1, which is equal to the refractive index of medium 2 upon refractive index of medium 1, which will be equal to V1 by V2. See, here it is reciprocal. Here it is not V2 by V1. Here it is V1 by V2. So be careful, right children? So this is your relative refractive index, and refractive index is the property of the medium. It will not depend, it won't depend upon any other factor. It only depends upon the nature of the medium and the source of the light, means what color of light you are having, what is the wavelength of the light. It depends upon that, right? It does not depend upon frequency, because frequency is not changing, frequency is not affected only, right? So this is your refractive index.